This is section 2.5, zeros of polynomial functions. Give the possible rational zeros for this one. We have plus or minus 1, 2, and 4. And then over here in the leading term, we got plus or minus 1, plus or minus 3. Now all of these over 1 is 1, 2, and 4. Then all of those over 3 is 1/3, 2/3, 4/3. Find all the zeros of this polynomial. So the factors of 58 are 1, 2. I don't think 3 is. 4 is not. 5, 6 isn't. No. So I think we can just match this up. 2 times 29 and then 1 times 58. So let's try 1 synthetically. 1, -6, 37, -58. We're looking for the remainder to be 0. So 1, 1, -5. -5 is 32, and then 32, -26. So no remainder of 0. I think, well, let's try -1. I don't think this one works either, but you know, this is the process that we'd have to go through. 1, -1, -7. 7 is 44. 44 is -14. Let's try 2. 1, -6, 37, -58. So we have 1, 2, -4, it's -8, and that's going to be, what, 29, and then there's 58, and we have 0. So we have x squared minus 4x plus 29. So I don't think, that doesn't factor, but once we get to an x squared, we got it made because now we can use the quadratic formula. So 4 plus or minus square root of 16 minus 4 times 1 times 29, all over 2 times 1. 4 plus or minus square root of, what's 29 times 4? 6, 3, 8, 9, 10, 11, 116. So -100 over 2. 4 plus or minus 10i over 2. So that's 2 plus or minus 5i. So there's 2 of them, and we need x equals, let's do this, x equals that, and x equals 2. There are the 3 solutions. Find all the zeros of y equals this, and use Desmos or a graphing calculator to find rational zeros. So we can, let's use a graphing utility to help us out. So I plugged it in, and we see that we have -2, 0, and we have 1, 0. So -2 and 1 we know are zeros. Now we're going to use that information to find the other 2, because there should be 4 total. Oh, what was it? 2, no, -2 and 1. So I'll make a note, -2 and 1. So let's plug 1 in. 1, -5, -7, 13, -2. 1, 1, -4, -4, -11, -11. That's going to be 2, 2, and 0. Well, now we know that -2 works also, so we'll use the result and keep going, and then we'll get down to an x squared, because if we have an x to the 4th, we need to find 2 solutions, 2 zeros, to get down to an x squared. So 1, -2, -6, 12, 1, -2, 0. So now we have x squared minus 6x plus 1, and we need quadratic formula again. So x equals 6 plus or minus the square root of b squared minus 4 times 1 times 1, all over 2 times 1. So 6 plus or minus the square root of 32, 32 over 2. That's 6 plus or minus, I think 16 and 2 is in there, so 4 square root of 2 over 2. So 3 plus or minus 2 square root of 2. So there's 2 of the answers, and let's make sure we write the others. X equals -2, x equals 1. So there's all 4 answers. Your turn. Find all the zeros. This is what you would do if you were sitting in class here. Find all the zeros. Use Desmos to find the rational zeros. So I plugged that equation in also, and we see that -2 counts an even amount of times. So let's assume that -2 counts twice, at least twice. because it's bouncing. It's bouncing off the x-axis there. So -2, 1, -2, -7, 28, and 52. 1, -2, -4, 8, 1, -2, and that's 26. That's going to be -52, 0. Let's try -2 again. So we have 1, -2, -6, 12, 13, -26. There's 0. So we have x squared minus 6x plus 13 left. So we want that to equal 0. So x is equal to 6 plus or minus the square root of b squared minus 4 times 1 times 13 all over 2 times 1. 6 plus or minus square root of 36 minus 52. 36 minus 52 is 16. So -16 over 2. So 3 plus or minus square root of 16, -16 is 4i, so 2i. And then x is equal to -2. So here, and writing that. Those are 4 answers, because remember, -2 counted 2 times. Find an nth degree polynomial function with real coefficients satisfying the given conditions. If you're using a graphing utility, we don't have to do any of that. All right, so we want to have a polynomial of a second degree, and here are the zeros. But we don't want any fractions. So our polynomial is equal to 3x minus 2, because if we set that equal to 0, added 2 over, divided by 3, we would get 2/3, times 4x plus 3, right? Because we would minus 3 over, divide by 4. So we have 12x squared, 9, and -8, plus x minus 6. How about this one? 4th degree, and then f of 1 has to equal 100. So let's do this first. Let's multiply x plus 4, 3x minus 1. So that's for the -4. 3x minus 1 is for the 1/3. And then we have x minus 2 plus 3i, and x minus 2 minus 3i. Well, we can FOIL these. 3x squared. Outside is -1, inside is 12, so plus 11x, and then minus 4. Let's do this. Let's run this negative through and regroup. So x minus 2 minus 3i. So we ran the negative through, regrouped. Let's do the same thing here. Let's run the negative through and regroup. Like that. And what we do is, what this is, we've created the difference of 2 squares. So when we multiply this, let's bring this down. We have x minus 2 squared. There's first. Outside and inside now cancel each other out. And then last is minus 9i squared. Let's just keep bringing this down. We have x squared minus 4x plus 4 plus 9. So now we have 3x squared plus 11x minus 4, x squared minus 4x plus 13. Let's distribute the 3x squared through. 3x to the 4th minus 12x to the 3rd plus 39x squared. Let's run the 11 through. 11x to the 3rd minus 44x squared. And then 13 and 11, 143. So then plus 143 x. And let's run the -4 through. So -4x squared plus 16x minus 52. So here's our final answer. 3x to the 4th minus x to the 3rd minus, let's see, 48 and 39. That's going to be -9x squared plus 159x minus 52. However, we need f of 1 to be 100. So y is equal to some constant times all of this. So we want this to be 100 when we plug 1 in. So k times 3 minus 1 minus 9 plus 159 minus 52. So let's see. 100 equals k times 2 minus 9 is negative 7, 150, 151 minus 52. 2 minus negative 7, 152, 152 minus 52 is 100. So k is equal to 1. So we don't need that k at all. It happens to be 1. Find an nth degree polynomial function with a real coefficient satisfying the given conditions, blah, blah, blah. We got it. So n equals 3. So y is equal to x plus 2, x minus 1 minus 3i, x minus 1 plus 3i, and that should be it. So let's bring this x plus 2 down with it. Let's regroup plus 3i. We're going to regroup again, minus 3i. We have x plus 2. First is x minus 1 squared. Outside and inside cancel each other out. And we have, again, minus 9i squared. So x plus 2 times x squared minus 2x plus 1 plus 9. X plus 2, x squared minus 2x plus 10. And so we have x to the third minus 2x squared plus 10x. Run the 2 through. So 2x squared minus 4x plus 20. And we want this to equal 80 when we plug 2 in. So we want k times x to the third plus 6x plus 20. So we want this to be 80 when we plug 2 in. 80 is equal to k times 8 plus 12 plus 20. So 80 is equal to 40k, so k is equal to 2. So the final answer here is y equals 2x to the third plus 12x plus 40, because we distributed a 2 through there.